All right, here we are on section 10.2 on derivatives of exponential and logarithmic functions. So we're going to find the derivative of e to the x, find the derivative of ln of x, and other logarithmic and exponential functions, and also look at exponential and logarithmic models. So the derivative of e to the x, in the process of finding the derivative of e to the x, we're going to use, without proof here, the fact that the limit as h approaches 0 of e to the h minus 1 over h is equal to 1. Now, we're going to apply this four-step process we remember from 9.4 to our function f of x is equal to the e of x. All right, so remember, step one was find f of x plus h. So, well, e to the x is going to be e to the x plus h. And because of our rules of how the exponents work, that's really e to the x, e to the h. Now, if we're going to take this minus this, well, then we're just going to have this minus e to the x. Well, guess what? There's an e to the x in both of those, so that's going to be e to the h minus 1. And now we're going to divide by h. And so we have this over h. And so now we can just put that h under this piece here. And then we have e to the x times that. Now, we need to find the limit as h approaches 0 of that. So, we did all these pieces. So now we have to do this. Well, what did we say that this was earlier? Well, we said that that was equal to 1. And so if that is equal to 1, and we've already pulled this out in front, then it's just e to the x times 1 is e to the x. And so therefore, what we have shown using the four-step process is the derivative of e to the x is e to the x. And that's something that now we can use as kind of a rule. And that's what we're going to use looking at some of these match problems here. So our first one is find the derivative of f of x when f of x is 4e to the x plus 8x squared plus 7x minus 14. And we're using the quick method. We don't have to use the four-step process here. We're just going to go straight to f prime of x. Okay, well, now we have a constant times this. Remember, the derivative of e to the x we just proved is e to the x, so that's 4 e to the x. Now we can take this power, bring it down, multiply it by 8, so it's going to be plus 16 power 1 less x. That's a 1 times 7, so that's going to be plus 7. X goes to 0 power, so that's just going to be 1, and that goes to 0. So that then is our derivative. Simple as that. What about this one? Well, f prime of x is going to be what? Well, we bring that 7 down, so we have 7x to the 6th. And we bring the 5 down, so that's a minus 5x to the 4th. Uh-oh, what is that? Well, that is a constant. And so that goes to 0. And so we don't have anything here. So even though we think, oh, it's e to the x is going to be that, well, e to the x and e to the 3 are different. Remember, e is a number. So if we take that number to a power, that's going to be another number. And so that is a constant, so it goes to 0. Now we have minus 1, and now the derivative of that is just e to the x. Okay. So that would be what we get for the answer there. And again, the key to the whole section on this one was remembering this is a constant, derivative of a constant is equal to 0. All right, so let's stop there and we'll come back for some more.